All right, and welcome to this next video. We're now at the point of your experimental design when we want to talk about the data table. So first of all, when will you be recording data? And the answer is immediately, like right as you collect each piece. There's the word immediately. Right as you collect each data point, you should write it down right away. So it kind of makes sense to have it very well organized ahead of time. So you should make the data table first with a very organized table. So it takes a bit of planning to think about what you're going to record. Next question is, should you use a pen or a pencil? And the answer is you should use a pen. You should write the data in ink. That you might ask the question then, what if you get an inconsistent result? What happens if you get some bad data? The answer is you still record it. If you decide later on that the original one that you thought was bad, you can decide later whether or not you're going to keep it. So the plan will be, even if it appears to be bad, still record your data, draw a single line through it, and go ahead and collect the data again. So if something happened and you dropped the mass or the string broke or something, take the result if you had it, draw a single line through it, don't erase it. Later on you can decide whether or not you wanted to keep it. So for an example here, let's say if we did one of these and we said there was a problem with that and we needed to redo it. This is the way your data sheet might look. So you can still read the original 15.93 if you decided, hey, that something went wrong with it, I need to redo it. There's a few notes here I want to go over. So the first thing we can see about this data table is, and I've labeled that the first column, the tradition is to make the independent variable first and then put the dependent variable second. The next thing you can notice is that we do include units just in the title, so that way we don't have to write it every single time. You don't have to say 20.0 grams because you said grams at the top. The word that we use for the titles here is going to be same as what we're going to be using later on in our graph, so just try to be consistent in how you name things. Now looking at the entries, looking at 20.0 grams, you might be wondering, well, why did they put 20.0 and not just 20? I'm thinking that the scale that they used measured to the nearest tenth of a gram, so they included that last zero to indicate that's how precise their measurement was. So if your scale measured to the nearest hundredth, and let's say it was 20.01 or 20.00, you could include those digits as well. If it only measured to the nearest gram, then you might only put 20. So just kind of use your common sense there, and you'll notice that they were consistent the whole time to include that tenths zero. So in your lab, I'm hoping that you put the mass on the scale each time. If not, we're not going to worry about it. It's our first time. Looking in the other column, you can see that they did 3 trials for each one, and again, if you had one trial that was very inconsistent, let's say you had one that was like 17, that would be a good indication that you want to try it over again. So again, use your common sense and say, if I'm going to do 3 pieces of data each time and then average those numbers, then I would want those 3 to be fairly close together. And I think most of the time they're pretty good. This is 15.72, this is 15.28, that's half a second difference. So not too bad, but it could be a little bit better. At the bottom of the graph, notice that they put in what they kept constant. So they put that right on their data table. Might write a couple of notes too about how many data points. So more data points is better. I'm going to say 8 to 10 is usually a good minimum. Depends a little bit on the setting. There are some very famous experiments where they collect millions of data points. There's a few where it's just impossible because of the way the whole experiment is set up to do too many like that. Another one is the range of values. So the lowest amount here was 20. The biggest amount was 100. So this is the range that I'm talking about. Okay, so larger range of values for independent variable is better too. So if you can keep that range really large, it's good. And I would say usually a factor of 5. Is a good minimum. So what was the case here? Well, if I said the maximum was 100, so if I said the max divided by the min should be greater than or equal to 5. In this example, the maximum was 100 and the minimum was 20, so that was a factor of 5. So that would be a good range in the mass. Moving on to the next page. So still talking about data collection. Before you're going to start to graph, there's often little bits of things to do. There's a few calculations. Okay, so may have calculations to do. Because if I'm looking at that data table, I don't want to graph 3 points each time. So if you have multiple trials like we did here, you're going to have to average the trials. Now, if you find that one of the values is way out of line, let's say if this one was 17 seconds, like I said before, if one of them is way inconsistent, you might want to actually try to minimize the error, try to get your technique better, change your equipment setup, and go back and recollect some data. So average the trials. So if you have inconsistent data, you may have to improve technique or your setup. You might have to change something to get better data. I would like you to show your simple or your calculations just once. So here is an example of the calculations to do average. So if you needed to find the average time, you would add the 3 together and divide by 3. And you'll notice too, when you divide by 3 and you get all those 3's repeating, you do want to round off to the nearest amount, because if your calculations were accurate to the nearest hundredth, here your average time is still going to be accurate to the nearest hundredth. So you can round off to the same amount. This kind of sample calculation you only need to do once. To show your work, that is. You need to do it for all the trials, but you need to just show your work just once. The other piece that's being done here is that when they calculated the period, you'll notice they did the time for 10 swings. Some of you might have opted for 5 and some might have opted for 10. So you should also do that sample calculation as well. So if you had, say here, this 15.64 for 10 swings, so 15.64 divided by 10 is going to be 1.564. That would be seconds. This would be your period. So again, you could show that calculation once. Now you're ready to start doing the graphing. So what are you going to be graphing? You're going to be graphing mass using grams versus period, which is measured in seconds. And that will be the topic of our next video.